And this is what the 8th graders would do. And what we do is we ask for one volunteer, actually a couple volunteers. They will weigh themselves at the different planets. And then we get a second volunteer. They'll get their weight on Earth. And then at the end, for the finale, they will go ahead and not weigh themselves on one of the planets. However, the first student will have weighed themselves on that planet. And then I ask the students to go ahead and form an estimate on how much the second student would weigh, and they would then need to use ratios. So this is the introduction to space in terms of weight on the other planets. Fun activity. We'll go ahead and start out with a weight since we don't have any students here. The weight that we have are 3 8-pound weights, which is 24 pounds. And that is on Earth. However, the weight looks like either the scale's off or the weight's off, but it is 22.7 pounds. 22.7 pounds. What we'll do now is weigh these weights on another planet. And again, 24 pounds. However, in this case, it shows 22.8 pounds. So make sure that you've got 22.7 pounds that is documented on your form. Okay, next, what we want to do is similar to before. We're going to choose a planet. And right here, you see the size of Earth. Let's go ahead and do the moon. You see the moon. And as we said earlier, general rule of thumb, the bigger the planet, the more the weight. The smaller the planet, the less the weight, or celestial body in this case, which is the moon. And the exception would be for the gaseous planets, in which the weight may or may not follow that rule of thumb, and it may or may not weigh as much as you may think. What we'll do now is go ahead and put our hand on the moon so that we can go ahead and get the weight. The weight is 3.7 pounds. 3.7 pounds. And go ahead and record that. And initially you should have formed the hypothesis on whether or not the weight would be a lot more or a lot less, or not much more, not much less. And what we're using as far as the differentiation is if there is a 4-pound difference or more, then it is significantly more or less. The next celestial body that will go ahead and take the weight will be Mars. Here's Mars. Here's the size of Earth. Okay, form a hypothesis on whether or not you think it'll be much more, much less, not much more, not much less, or about the same. As you see right there, comparable in size. Let's go ahead and put our hand over Mars. Hands over Mars. You see 8.5, 8.5 is the weight, 8.5. Now, what's the reason why there was a significant difference in the weight? Let's go and do it again. See 8.5. There's Earth, and let's go ahead and choose Jupiter, which you see right here. Jupiter, compared to Earth, significantly bigger. It is a gaseous planet. However, you are a little bit more experienced now, so you can state whether or not you think it'll be much more, much less, not much more, not much less, and probably have the results support that hypothesis. Let's go ahead and put our hand over Jupiter. Jupiter, 65.3 pounds, 65.3 pounds. And your recorded weight of Earth was 22.7. So that should have supported or not supported your hypothesis. It was supported if you said that Jupiter would weigh a lot more than Earth. Let's now go ahead and choose another celestial body. Let's go ahead and choose Pluto, which it is a dwarf planet, which you see Pluto right here. You see Earth down here. Let's go back up to Pluto. Okay, Earth is significantly bigger. So form a hypothesis on whether or not you think Pluto will be much more, much less, not much more, not much less, or similar in weight. Let's put our hand over Pluto. 0.6 pounds, 0.6 pounds is Pluto. Pluto, 0.6 pounds. The weight for Earth was 22.7 pounds, which we'll show you right here again. Or 22.8. Next, let's go ahead and choose Neptune. You see Neptune up here? Look at the size of Neptune. Look at the size of Earth. What do you think? Much more, much less, not much more, not much less, or about the same? Neptune is a gaseous planet. It is bigger, as you see. Let's see what happens. Let's put our hand over Neptune. £28 or 27.9, or let's just say 28 pounds. And we said the difference would be 4 pounds. So it is a lot more, but maybe not as much as you may think, or we may initially think if you're going to base strictly off size. Look at Earth, look at Neptune. Let's now go and select one of the smaller celestial bodies. Let's go and choose Mercury. There's Mercury. There's Earth. You see both on the screen. Let's use the pointer. Mercury, Earth, Mercury, Earth. Okay, Mercury. Significantly smaller. Let's see what happens. Form a hypothesis on what you think will happen with a weight. 8.5, 8.5. 8.5 pounds is Mercury. 8.5 pounds is Mercury. Earth was 22.7, so you need to let us know whether or not you felt that supported or did not support your hypothesis, and make sure that you record it on this form. Let's now go to a larger celestial body. Let's choose Saturn, which has the rings. Again, Saturn is a gaseous planet. You see the size of Saturn compared to the size of Earth. A lot bigger. Form a hypothesis whether or not you think it'll be a lot heavier or weigh a lot more, weigh not much less, or about the same. Let's go and put our hand over Saturn. 30.1 pounds, 30.1 pounds, 30.1 pounds. Saturn. Okay, and we said 22.7 pounds was the weight of Earth. So it was a lot more, but maybe not as much as you may think. Let's now go over a smaller celestial body. We have not done Venus. Venus is the second planet from Mercury as far as distance from the sun. You see Venus, you see Earth, Venus, Earth. Looks like a little bit smaller. Let's see what happens. It's Venus. £20.5 pounds. 20.5 pounds is Venus. Venus, 20.5 pounds. So did that support or not support your hypothesis as far as it being much more in weight, not much less in weight, or about the same? Or a lot more or a lot less? Okay, our final planet. We'll say it'll be Uranus. Form a hypothesis on how much it's going to weigh compared to Earth, and go ahead and use ratios. Compare the other weight, the 8-pound weight, as compared to Uranus. Make a ratio using 22.7 pounds so that you can figure out how much 22.7 pounds on Earth would weigh on Uranus. But initially, as you notice, the weight of Uranus is a lot bigger than Earth in size. It is a gaseous planet, so it may or may not follow that rule of thumb. Let's go ahead, put this on Uranus. Hey, 21.2 pounds. 21.2 pounds is Uranus. Uranus, 21.2 pounds. And earlier when you weighed that 8-pound weight, you noticed that the weight on Uranus was less than Earth. Well, same thing. You should have at least come close to the weight that you got for Earth. In this case, Uranus, 21.2. Okay, hope y'all had fun with this. That is what the weights would be around the galaxy. And I will look forward to seeing y'all out here, though, at the Flight Adventure Deck in the future. So please encourage your teachers to go ahead and bring you out here. Take care.